And cycles to work on a front-end language because I think it might highlight some strangenesses that I don't understand. So in an EVD, you are allowed to have an expression which is the composition of EVDs. Yeah, I think we should.
Hello. Hello. Yikes. Just double checking that can people hear us that are online? Yes. I think.
Virtually.
Yeah, I can hear you.
Oh, excellent. Thank you, Simon. All right. So certainly one of the dangers of being right after lunch is I think we might have some people trickling in as we go, but I think it's time to get started. So with that in mind, welcome to IETF 123 DTN Working Group. Let us get kicked off. I wanted to start by going over, even though we are somewhat late in the week, just understand that we are still under the note well, that we do have an IETF code of conduct. We like to be hard on ideas, but not to the individual. Again, general meeting tips. If you have questions and come up to the mic, please join the queue. Please keep your audio and video off if you're not otherwise presenting, just to help. The resources for DTN Working Group are all in the standard places. And here is the link in the chair slides for the full MediaCo client, but again, please join. I would ask that if you are willing to please join the shared notepad and take minutes. The more minutes and the more people we have taking notes, the better. And I wanted to take a moment and just sort of look at where we are right now in terms of the documents that we have in the working group. We most recently published the IPN schema update, RFC 9758. We have, just before that, several months prior, published a autonomy management architecture for DTN. That was RFC 9675. And then we currently have 11 adopted drafts that are being worked on, some of which will be presented today. And I just took a screenshot of that on the right. And then we have 7 unadopted internet drafts that are out there, some of which will be presented now, some of which may be presented later. And then that may feed into what will become a charter discussion at the end, which is we have many adopted documents. We have other documents that are asking to come in otherwise, and we should talk about that in the context of our charter. Otherwise, we have some slight updates to the agenda and the schedule other than this introduction. We are going to have co-op over BP. Brian Sipos will be doing several updates for some of his drafts. DTMA updates, then Rick for BTPU, Scott and Alberto for bundle and bundle encapsulation, Scott for an update to the DTN architecture, some discussions on reliability, strong bundle, auditing mechanisms, and then the recharter discussion. Let me pause here and see if we have any requests to update or change the agenda.
I have one point. So Xi Jinping is not available for that. So his co-author Benjamin Dowling will be speaking on his behalf. But
excellent. Thank you, Benjamin. The one bit of agenda bashing we do have is our AD would like to get up and say a few words. And instead of doing that at the end, why don't we go ahead and kick off with that? So we would invite Eric up for an update.
Thank you. Yeah. So just a reminder that this is the part of the annual cycle where the NOMCOM has released the list of positions that need to be filled. That includes INT AD. So If you want to be an AD or you want to be on the IAB or fulfill any of the other open positions, I encourage you to go look at what's open and read the job descriptions, and you should apply. You can nominate yourself. If you don't want to nominate yourself, you can tell me and I will nominate you for you. That's fine. But please do have a look, and please consider serving in a leadership position. Thank you.
All right, thank you, Eric. So then, otherwise, we do have a pretty full agenda today. So let's get to it, and let's start with an update on COAP over BP. Let's see how
No, I don't want a software update. Yes.
And the previous working group took the dongle for that, I think. So I don't know if it will work. If not, I can flip your slides.
Have you, oh, I haven't got the slides because I'm an idiot. Where? Manage slides. No, don't. Why can I not see? Where are the slides gone these days?
Oh, I can share it. Sure.
Being
There
an
you go.
idiot.
Okay, hello everyone. My name is Carlos Gomez, and I'm going to present the main updates and the current status of the draft entitled Constrained Application Protocol COAP over Bundle Protocol. My co-author is Ana Calveras, and we are both from UPC. Next, please. On the status of the draft, we requested working group adoption at the core working group. This was a couple of days ago. Previously, there had been a discussion between the chairs of the DTN working group and the core working group, and the decision was that the home working group for this document would be core, but we would still keep presenting the updates also in DTN, and of course, welcoming your feedback. And the in-room working group adoption poll results from the core session were the following: 13 votes in favor, 0 against. The document is currently in call for adoption state, and there's an open confirmation call on the core working group mailing list. Next, please. We have updated the document, adding a few sections and subsections. A couple of them relate with the functionality of message aggregation, which, by the way, was suggested originally here in DTN. And also we have added the section on implementation status. Next, please. So on the main updates, first, there is section 4.3, where we already had defined a new COAP option, which is called payload length option. This had already been presented previously. Recall that this is an option that indicates the COAP message payload size, and it's intended to enable message aggregation, because an aggregate message would be a concatenation of single messages that carry the payload length option. And the point is that there has been some discussion about this topic. There has been even a dedicated interim core working group session on this, because there was the suggestion that perhaps we might want to convey payload length information, not as an option, which requires a bit more processing for a receiver, but perhaps as part of the fixed part of the COAP message header. But then there was also the issue that, yeah, we could do that for COAP over BP specifically, but then we might also want to be able to support this functionality over other transports, like say UDP, which is the default transport for COAP. So the current consensus is that this is the way we should follow, which is based on defining a new option. Then we've also added details on when we have a COAP message that we want to protect with OSCORE, which is object security for COAP, and we also want to add payload length information there. The process would be as follows. First, the OSCORE message would be created based on the original COAP message as an input. The result is a larger COAP message, which is called the OSCORE message, and this expands the total message size. And then after that, the payload length option is inserted in the OSCORE message, and the payload size indicated finally by the payload length option is the OSCORE message payload size. Next, please. Then we've added a section on proxy operation and message aggregation. We have written that the proxy that supports message aggregation disaggregates a received aggregate message and then proceeds handling the individual messages normally as specified in the base COAP document. And we've also added that the proxy as a co-op endpoint may also aggregate messages destined for the same endpoint. So for instance, in the topology shown here on the slide, perhaps client 2 may want to send a request targeting a resource at origin server X, and then client 2 wants to send another request targeting a resource on origin server Y. Then the proxy may aggregate the responses that need to be sent back to client 2. Or in another example, client 2 may send a request targeting a resource at origin server Z, and maybe client 3 may want to do the same. And if the proxy really needs to forward those requests physically to the origin server, the proxy may also aggregate those corresponding messages. Next, please. We've also added a section on implementation status as recommended by RFC 7942, which is a document that it's intended to increase awareness of running code corresponding to internet drafts. And by the way, this would be a section to be removed before eventual publication of the draft. And the main content here is 13.1 on an implementation called Space Co-op, which has been developed by UPC, the main people being Michael Karpov and Anna Calveras as developers. And it supports scenarios with and without proxies. By the way, it's based on AIO Co-op and Micro D3TN for Co-op and BP respectively. And it's compliant with the previous version of the draft. So it already supports features like the payload length option and message aggregation. The level of maturity at the moment for the implementation is research level, and you may find more details about it in the draft, also in an annex at the end of this slide set, and there's also a link to a demo video that you may check on the slide. We've also added a short section on other implementations that in the past were developed for Co-op over BP, like the ones mentioned here. However, it's important to note that those implementations don't comply with our draft, or maybe vice versa, because they were created before this document. Next, please. Yeah, so that's all the slides I had for my report. Any comments?
No comment other than just thank you for the update, and thank you for keeping the DTN working group up to date on as it progresses.
Thank you.
All right. Coming. Oh, I'm sorry.
sorry, go ahead,
Eric's
Eric.
in the queue. I'm like, what's happening? Yeah.
I think we need to have a discussion about IPN.ARPA and whether or not we want the names to be publicly resolvable or not. I was reading your description in there, and I understand it's perfectly useful to have a .ARPA name that actually isn't meant to be sent in the wild and served in the wild. I kind of think it would be cool if it could be served in the wild, because you could actually hang CLA RRs off of an IPN name in IPN.ARPA. You could take an IPN, look it up in DNS, and get the some resource record that tells you how to get to a TCP CLA for it, for example. I mean, what you have written is fine and makes sense, but it also precludes, on purpose, broader use in the internet. I don't know if that's what the community wants to do.
So, Eric, chair hat on, it would be great not to put a block on the progress of this document. So could you do a scrub of the DNS-ish bits that are in this document, just to see if you see a potential conflict between what's being done at the moment and what you would like to kind of do, making it actually DNS connected rather than just a unique identifier, just in case there are changes you could push back to the author team?
This is the point that I would raise. I think though it's a separate discussion about how IPN.ARPA would have to be managed so that you could delegate it to the allocators. And what I'm afraid of is that to do it, I won't say right, but to do it, to delegate it properly, would have to involve standing up a delegation process and allocator. People who had received an IPN allocator would have to give name servers, list of name servers to whoever operates IPN.ARPA, which I think probably in the end is Wes. But anyway, yes, I will attempt to engage. I will also ask maybe DNS Directorate.
That would be really helpful.
Have you had a DNS Directorate review as the document?
Not yet.
Not yet. Okay. Yeah. Thank you.
So I think concerning DNS Directorate review, given the usage of URIs within COAP are not DNS resolvable, they're just DNS-like, I don't think it's a blocker, as I understand COAP, and I may well be wrong here.
Maybe we can change it too. Maybe you can publish this as is, and if we do decide to make it globally resolvable, we can just do an update document.
That would be my suggestion. So my request is have a quick scrub of what's in there, just in case there's something that stands out for how you think it should be resolvable. It clashes with the way these URIs are being used at the moment. I don't think they are, but have it.
Yeah, no, 100%. Yeah, just what I need, another action item.
Thank you.
Thank you very much.
Thank you, Carlos.
Next up, we have Brian Sipos. He is working on a number of documents for the working group and is to include some that have not yet been adopted, and we have a status of all of them.
Brian, are you okay to take control of the slides yourself, or do you want
I
to share?
can. Do I push the request button?
I will click accept if I see the request.
Okay.
Yes.
You got it.
You have, oh, you have to stop sharing.
I have to stop sharing. Oh, for God's sake.
There you go.
All right. There we go. So this is a brief summary, a status of a few different drafts at different levels of progress. The most mature is going first, and that is the BPSec COSE context. There actually has been a slight discussion on the mailing list after this had been written earlier this week, but the last changes here are to add the security source to the AAD to address an earlier issue that was identified and discussed. And some clarifications were made to the AAD procedure, not to the actual structure, but just to how it was defined and described to make it a little more hopefully clear about what the contents are. That was based on implementation feedback, and I appreciate that feedback. And there was also some fixes in the examples that were actually also good catches that don't affect the contents of the body, but are really COSE related, not BPSec related at all. And at this point now, there actually are multiple implementations in different languages, at least 2 at this point. There hasn't been any interoperability work done yet, but at least having them there and having them able to process the examples at least, or produce examples, is a good status. So at this point, I think that this document is ready for a working group last call. So I can propose this on the mailing list after the meeting as well, because I think it's pretty stable now.
Just chair hat on, agree, and would ask that the request be made on the mailing list, and we will respond from there.
Mm-hmm.
So chair hat off, I've joined the queue like a good boy. I have one concern which may or may not be directly relevant to the COSE context, which is time. I know the COSE, so my concern is that if you have a bundle that is signed sometime in the past and it has rested at many places across the network before some verifier or decrypting function wants to actually decrypt it, using the key that was used to sign sometime in the past, despite the fact it may have rolled over while the bundle was in transit, means the job of a verifier is much harder. It must run backwards through a list of all the keys that might have been used. simply because the BCB or the bib may have been applied to a bundle by an intermediate node after the bundle was created. So the bundle creation timestamp doesn't give you a definitive idea of which key to use, and definitely, you know, prior to when you're trying to unvalidate it. So I know the Cozy guys have some work on time stamping, and I'm not a security guy, so I'm trying to unpick what that means. The question is, given RFC 9173 as it stands at the moment is a very primitive security context and is there for interoperability. And I think that the Cozy context can be a really good general purpose context for production use in DTNs. Should we try to address, and how do we address, the problem of working out which key to use based on a time series of keys? Should we try and fix it within?
So I can definitely say for that specific issue, there is guidance and requirements in the draft as it is. This is something that, similar to your other comment on the mailing list, is worth probably security consideration, just to reiterate that. It's a bit of an arbitrary choice, but at least it is a concrete choice that everybody can agree to at the current moment. And it's also similar to other things like the security source, EID, and other properties pre-verification. They're all untrusted guidance, like you said, about narrowing down which keys are appropriate.
Okay, so I'll go back to the list. I'll try and review that, and I'll take it to the list. Thanks.
Okay, and just as informational, the COSE draft or pre-pub draft about the timestamping, that is about secure timestamping from a trusted source. So it's a little bit of a different activity than this kind of key filtering informational timestamp.
That was my read as well. I'm not sure it's the right tool here. Okay, thank you.
Yep. The next up is the EID patterns draft, which there had been some recent changes about optimizing range notation, but without changes to really function, just changes to the notation in text form. There have been now multiple implementations here in different languages. There's still this open caveat that this focuses solely on the IPN scheme as the one that is the most matured and the most structurally understood. That is the current state of this document. There had been some earlier suggestion about could some forward-looking pattern syntax for the DTN scheme be proposed. There isn't right now, just because there hasn't really been discussion about what forward-looking looks like and specifically what the authority part of a DTN scheme EID is supposed to look like. So this is status on the current draft. I think it's valuable to simply have this in place and focused on the well-structured IPN scheme. I think there's value in having this separate from discussing other schemes that could be patterned. So this is, if there is no other feedback, I think this is ready for a working group last call, with the possible outcome being last call comments say, I can't live with this without a DTN scheme pattern. And I see Eric's in the queue, so I'll give him some time.
Yeah, just with AD hat on, if somebody were to try to say that they want some pattern matching for DTN, I think the first thing to push back on would be, please specify what the format of the authority is, because 9171 doesn't at all, right? I mean, you could say like wildcard syntax applies.
Yeah, that's really the challenge at the moment.
Yeah.
So I think that shouldn't hold us back.
So from my perspective, Rick here, sorry, I completely agree. There's been the previous version's regular expression syntax was very rich to try and handle that case. there's proposals about using glob patterns, but you're right, we don't know. So chair hat on for a second. I'm going to do a quick show of hands because, and the question is, do you believe that the EID, should this document include a pattern syntax for the DTN URI scheme? Because if the answer is no, we can just move ahead with this document and get it done and dusted and just concentrate on the IPN scheme. So a quick show of hands because we've got a busy schedule.
And to frame it also, it's not to say that there never will be, just to say that this document does not.
Oh yeah, completely. It's this document. It doesn't mean the working group shouldn't work on it. It doesn't mean an updated document in the future or a new document shouldn't talk about that once we have a clearer idea of what the DTN URI scheme is. No opinion is obviously a perfectly valid answer. The voting has stabilized. I'm going to call it at that point. Oh no, there we go. Well, I'll tell you what, I'll let that tick and we'll move on.
Okay. Next status is on the updated UDPCL. At this point, what's written in the draft has had one trial implementation of all the behaviors that are defined. Part of the point of this update is to add extensibility and a segmentation capability in this CL, so it brings it up to parity with proposed standard level in IETF, whereas the previous draft was experimental. The current draft includes what I'll call a secondary menu of useful extensions that are really specifically for IP capabilities. These are things like ECN support. These are things about how to do path MTU detection, deferring to another document that gives the actual algorithm for doing it. This is just enabling these other things to happen, not building them in. And it would be useful to get some feedback from the mailing list about some text to explain this in the introductory portion, because the point here is to say that these things exist and here's how you would do them interoperably if you want to do them. None of these extensions are mandatory to use. That's the main point of this thing. So I can come up with some text, but it'd be also helpful if anybody else has some proposals or some references to similar existing.
So chair hat on again for a second. I think this is a really useful document for a number of reasons. It updates the existing IRTF UDPCL to handle all the things you need to consider with running UDP across a congested public internet, for example. So it is an important document. However, for a CL of this complexity, for the environment where it has to play well with others, I think more than one trial implementation is probably required. I personally I'm very happy for this to rumble on in the working group as a possibly stable document, which just requires a bit more implementation, perhaps a bit of interoperability testing, just to make sure we get it right so that when it hits the IESG, we are really happy with this one. Does anyone want to jump to the mic and say, no, you're completely wrong, and they need it now? And if they do need it now, can they do an implementation and tell us how good it is? Does that work for you, Brian, as you're kind of driving the document?
It does, yeah. And one of the things that brings it out of that experimental realm is nothing to do, things that are not to do with what goes on the wire, but things to do with you should use stable port numbers. You should use consistent port numbers, like things that are not about the encoded form, but just about how to do things in a way that are going to be compatible with middle boxes and compatible, like you said, with a real network use. So that's fine for it to sit as is for now.
No worries. Just again with Chair Head on, I know we only have about 3 minutes left here and that we're already just a bit behind schedule. I think we can close the poll with no yeses in terms of the DTN pattern, and then let us proceed.
Okay. I'll mention status for the secure advertisement and neighborhood discovery. There has been a trial implementation of, I'll say, many features here. This document is still in the phase where it's trying to figure out what ought to be advertisable as a starting point and how those things need to be parameterized in order to make them usable. It's a really an early draft as far as the detailed structure, but the overall goals are there, and it's something that could be implemented, could be tested. There could be some interoperability work done here. And just to know, the current detailed definition does depend on UDPCL as a zero configuration default convergence layer, but doesn't necessarily have to use that. Does depend on IMC scheme, again, for the same reason, and EID patterns for some of the advertised capabilities. So there's cross dependencies here. And as you can see, it's a 0-0 draft. This is still early, a lot less mature than the rest. So I'm going to continue on with the slides. We did cover actually these open discussions already. And I'm going to consider the COSE context and EID patterns on the mailing list as requests for last calls. And just here's some references about the open issues on SAND that need to be discussed. And it's early for this stuff. But if anybody has suggestions or feedback, that is definitely welcome. There is a new personal draft that was released just after the last IETF, which is an attempt at security associations with few exchanges. The goal here is to have a kind of a in-band control for negotiating security associations and negotiating the use of BPSec so that nodes can operate more autonomously in a way that doesn't require a central controller to tell them how to work. And it's leveraging existing ad hoc protocol and existing other mechanisms. So we're not trying to invent security, we're just trying to embed it. I'm going to flip through really quickly. Folks can read this offline, but some pointers to what SAFE is trying to do in more detail to cover at least 2 use cases to start with that are very simple but very powerful. And then an explanation of the layering and a couple of issues that are known. But I believe this does fall under the existing scope in the working group for key management. So I don't think it's not an adopted draft, but I think it falls in that realm of the charter. And I think that I don't need any more time. We've talked about that poll about the DTN scheme specific, and everything else below that is really it'd be useful to have implementation experience, as Rick mentioned.
So on the DTN scheme, the result of the poll was nobody wants to hold that document waiting for the DTN scheme. So let's proceed.
Okay.
And a request for SAFE, if you would put the request for adoption on the mailing list as well, and then we can decide from there.
Okay.
Thank you for
staying
staying in time, Brian. Thank you.
Next up, we have Justin Ethier from to talk to us about delay tolerant network management updates.
Hello, can you hear me?
Yes. Would you like to share your screen, or would you like us to share the slides?
If you don't mind, Ed, if you could share the slides.
Okay. Can bring them up. Oh, you have them.
They're not in order. Sorry.
No, that's okay.
Let's cancel that timer. So I can use
All right.
All right.
Thank you. My name is Justin Ethier. I'll be talking about the status of the DTMA drafts. All right, next slide, please. And I'd like to preface this before I get started on the drafts. Basically, these updates and any pending changes are refinements to the existing drafts. So the fundamental concepts are in place and have not changed. So jumping into the AMM document. So first of all, we've included namespace references as a full member of the built-in AMM type system. So these references include the organization ID as well as the model components of the ARI reference. We've also made updates to ident objects. So we now allow the creation of ident object hierarchies, allowing a abstract ident to be defined, as well as the ability for other idents to reference that abstract ident as the base object. And this allows introspection of semantic types within the AMM. Within the AMM. AMM values must be combated by omitting type information if it can be inferred by the context of use. We've also extended the list of ADM author considerations, and I'll come back to that later in the slides. And then for the ARI documents, we have updated that to allow the structuring of object reference parameters as either a list or a map. We've also added recommendations for interoperability using existing well-known media types. And we've expanded the IANA DTMA object type registries to include a range of reserved type values for experimental use. And finally, we've added exec set and report set examples with a comprehensive set of ARI variations. We found that helpful for people new to DTNMA. And moving on to the AMP documents, we now support transports for cases where the ultimate destination endpoint is not available. And we also require AMP messages to contain one or more binary form ARI values. Next slide, please. So this is a list of the representation of the normative references for our previously discussed drafts. So the AMP document that discusses transport has normative references to the BPv7 and BPsec RFCs. Our ARI document has references to the URI and CBOR RFCs, and then our AMM document has normative reference to the primary DTMA RFC. Next slide, please. And just going to discuss a couple sort of highlights of the updates. So first of all, we have these updates to the application data models. So the IETF AMM at the top there in blue, that has been expanded into a AMM base ADM, which contains all the base objects, and also it's been expanded into an AMM semantic types ADM. And then the existing AMM ADM remains with list of extension keywords. So just putting these in more appropriate locations. The IETF network-based ADM has been expanded out. There now also is a INET-based ADM as well as a BP ADM. And our DTMA agent ADM has been updated to include new definitions for ODM introspection, as well as definitions to assist with maintenance of autonomy rules. Next slide, please. And the ADM author considerations, this was a component of the AMM document previously, but it's been significantly expanded in this update. And the idea here is it's not a list of sort of syntax or anything like that. These are really best practices for usability and maintainability of ADMs. And so we recommend any new ADM authors read this, take these recommendations into account as you create your own ADMs. And there are some highlights here. I won't go over all of them now in the interest of time, but again, we recommend new authors or really anyone that's looking to create an ADM, please read the document and refer to the author considerations. And next slide, please. And it's a list of our open issues and work. So we're working on providing a full definition for ARI object reference patterns. The work is ongoing. We are looking at the access control specifications, and we're planning to update those, make some adjustments to make them fully implementable and extendable. There's ongoing work implementing the remainder of our existing ADM objects. So we're performing that work as part of our reference implementation. We're looking at adding model features. So the idea here is that more lightweight agents would not necessarily have to implement the full set of or full components of an ADM. Certain components could be used or not based on a feature set. So we're looking at adding that capability as it makes sense. And then we have some follow-on ADM work, including alarm state management, log management, and host OS telemetry. And that's all I have. Thank you.
All right, Justin, thank you very much for the update across those documents. Just pause for a moment to see if there are any questions related to it.
Yes, I shall join the queue. Chair hat off. Justin, on your last slide, the final point was you were talking about alert management and telemetry and so on. How are those new constructs for the ADM, or are they just controls, reports, and triggers?
It would be new. It would be controls, EDDs, those sort of things. So it would be objects as part of the ADM, but not new fundamental ADM concepts.
I shall correct myself because I've just reread that book. You said follow on ADM work, which explains it. It's not follow on AMM work. I misread that. I withdraw.
Oh, no worries.
Right. No worries. Thank you very much. And we will move on. Our next presenter is Rick to talk about BTPU.
Got it. Right. I'm going to keep this really quick because there's not a great deal to say and we're running slightly behind. Next slide, please. So adoption is now complete. The documents as were have now been renamed. So they are the BTPU and the BTPU FEC are now draft IETF DTN hyphen insert name here. There have been no changes to the FEC document. I have literally renamed it and resubmitted it. But there has been one significant change to the BTPU document. Next slide, please. So based on I think, strong recommendation from Brian, a good recommendation from Brian Cepos, the numbering of segments of a transfer has now been inverted. So it goes from high down to 0, whereas before it was 0 to the last segment index. The reason for this, I think, is twofold. Brian's good suggestion was it allows a receiver to have a handle on how many segments it's going to receive, so it can pre-allocate buffers, it can assign some resources to it, or decide to just ignore the transfer, which is a perfectly valid operation. It also actually means we no longer have a transfer end message saying this is the last segment. We now have what feels nicer, which is a transfer start message. It just feels a bit more natural. So I quite like that. There was an open question of whether this inversion of the numbers affects streaming in some way, because in other protocols where a sequence number is incrementing, you can start processing before you get all the bits, etc. I don't think that's applicable for BTPU. I don't think we have a streaming concept. So I don't personally think there's an issue, but I'm totally open to people to discuss this. Mailing list is the right place for it. Next slide, please. So I'm considering 2 more changes, which I will suggest to the working group because this is now a working group document. I think there might be value in the 24-bit segment length is 24 bits so that we have a nice 32-bit header and get some nice alignment features for fast FPGA work or whatever. I'm suggesting that perhaps we steal 8 bits off that and make it a flags field. So we have a type field, 8 bits, a flags field, 8 bits, and a 16-bit sequence length, which is still plenty because I don't know of any 24-bit length framing technologies out there. It seems massive. That flags field would allow us to insert optional headers into those early messages, into the message between the common header and the content. I can only think of one potential use for it, which would be to perhaps give an optional indicator of the total length of the bundle to a receiver because it might help it in some way. It's one of those cases where wouldn't it be nice to have a flex field that we could use if someone comes up with a great idea, because 24 bits seems a lot of space. Should we get it in now rather than later? I don't know. The second change I want to make, which I think is probably more important, is to reserve message type 6 and the message types of the range hex 80 to hex 9F to demux frames that just contain a raw bundle. So type 6 is the first octet of a BPv6 bundle, and the range 80 to 9F is the CBOR encoding of a BPv7 bundle, including the non-canonical fixed length array format. This might help in cases where the underlying link layer is running raw bundles in some frames and BTPU segment messages in other frames, and it would allow a process to be able to directly tell each other. If we used message type 6, then we would stamp all over a BPv6 bundle in a raw frame. I think it's probably a sensible thing to make space for that at this point. I've got a shout out to Eric Klein, who's kind of thinking about if we were to run, next slide, it's on the next slide, sorry, next slide please. So there's some derived work. Bundle protocol over Ethernet is take BTPU and run it over Ethernet frames. Go register a protocol type for Ethernet, add the IANA subslice, and I'm name dropping Eric here as an effort to try and, he and I will try and get this done. The slicing out of those numbers and the demux is kind of driven by the, if you've got Ethernet frames in a single protocol type, how can you tell whether you've just got a raw bundle in a frame or whether you're running BTPU, and can we look at how some of the UDP-CL payloads also could fit in there? So that's there. Bundle protocol over EPP and AOS is really important. It's in specifications, people talking about LunaNet. That's what they're going to run. And BTPU solves a big complexity problem in getting big bundles to run over these space framing protocols. Third thing, bundle encapsulation, trying to solve fragmentation, and we're going to hear about this in a minute, will require some segmentation. We can look at the UDP-CL v2 segmentation, which is quite elegant and done in CBOR. Unsurprisingly, it's very similar to the BTPU segmentation rules because I lifted it, because it's well thought out. There's some crossover. We'll end up, I think, with a segmentation algorithm that's pretty much derived from both. But there we go. That's where we are at the moment. Please keep reading and reviewing and spotting typos and suggesting ways that it could be improved. But chair hat on for a second. I'd quite like to get this moving forwards towards standardization so the derived works can really start to go. That's it.
Oh, no, thank you, Rick. And we have Brian Sipos in the queue.
Yes, I think the current state of the base BTPU is good, and having that specific underbinding to Ethernet or whatever really is necessary, because without it, you can't really test or interop anything.
Completely agree.
You have to pick some.
Yeah, it's currently a general process for doing it without actually any real detail on how you would do it on a particular framing protocol. So yeah, thank you. I agree completely.
All right. One more. Yes.
Do you want to join the queue?
I just don't have my clicker on it. Yeah, so I'll be...
Sorry, can you state your name?
Alexander Pelov. Sorry, I'm going to join the queue then, so I can see it. Yeah, Alexander Pelov. So I'm working on SHIC. So I'm the co-chair of the SHIC working group. And so in SHIC there is fragmentation. So just and it's basically bringing a lot of things, like bringing non-IP protocols to the IP world. So probably you can look at that, right? If you're looking for fragmentations there. And I will be interested in knowing what's the use case for bundle protocol over Ethernet. So is there...
so the use case, as we understand it, Eric, unless you want to say something about this because you're kind of driving it, or I can... Okay. Bundle protocol over Ethernet, we are seeing people experimenting with using Ethernet for optical intersatellite links. As it's available, it's layer 2, people know how to use it. Also for internal buses on spacecraft. So your radio system is across an Ethernet bus from the BPA itself.
Okay, because right now also we're going to have an Ether type for SHIC. So probably you could do stuff with it. Like, I mean, it's the first time I'm seeing this thing, so I'm just saying that there are probably things that could be used together.
So Schick is on my list of things to check, even if we just make sure we are demuxing that first byte correctly so that we don't stamp all over each other. I think that would be a good step. There is a difference between, I believe, and I need to read the Schick documents more carefully, there is a difference between what we're trying to do here, which is reduce the various protocol layers to say we can go from bundle straight to link layer with minimal extra encapsulation. Whereas I think, Schick, you're trying to say, let's compress all those layers of headers to try and make it efficient. However, let's absolutely make sure that we're reusing any crossover technology and make sure it's, so thank you.
Thank you much. Chair Hunt, on a comment, which is, I think that's very interesting, and I can't wait for us to explore that. And I do see, just Eric in the queue as well. Also Eric in the queue as
well. Just one observation about Ethernet is that it's the draft is tries to state that it's over Ethernet or Ethernet-like links, because there's a whole universe of things that are not Ethernet that still pretend to look like Ethernet. So,
yeah. Fair point. All right, thank you very much, and thank you, Rick. Next up, we have Scott Burley and Alberto Mantilla, who will be talking about bundle-in-bundle encapsulation. Scott, would you like to share slides in your screen, or would you like us to share slides?
You've got Alberto's slides as well?
I only have your slides.
Okay, so there's no advantage in doing them from your end, so I will go ahead and share from my end.
Thank you, Scott.
Oh, damn it, I just canceled your time.
That's okay. All right, there you go.
Oh, so screen share. Do I need to share my entire screen? Is that how that is going to work?
Wait, I don't know, but you have been given permissions to share screen.
Oh, okay. I think it is all right.
Oh, we see it. Yes.
Okay, good. Okay, I've just got 4 or 5 slides here, and then I'll turn over to Alberto. The current status of bundle encapsulation, there was a draft that was posted on the 15th of March. That's the most recent IETF documentation on bundle encapsulation. It's very small changes from the earlier 2 drafts. And there are currently, I believe, 4 implementations of BIBE for BPv7, and there's been some interoperability testing among those implementations, but not comprehensively as far as I know. The revisions that have been proposed in the most recent set of Consultative Committee for State-Based Data Systems working group meetings in June come down to, I believe, 2 significant changes. One is the idea that the retransmission mechanism in BIBE, adapted from custody transfer in RFC 5050, should be removed from the protocol. It makes BIBE more complex, certainly, and there are very similar procedures being proposed by folks in CCSDS on the Orange Book for compressed custody signaling and bundle status reporting, and that work might eventually find its way into standardization in IETF in the future. There is, I think, broad working group consensus on adopting that change and removing the BIBE retransmission mechanism from bundle encapsulation. The second significant proposed revision. Yes, go ahead.
Sorry to interrupt, but we are not seeing your slides advance on the shared part of the screen. We're still on the title slide.
Oh, okay. So maybe that's because it's in full screen. Maybe that's not very good. So
We've seen it advance now. We're on revisions proposed 2 of 2.
Yeah, and you're seeing the editing presentation, right? So they're just fine.
That's correct, and that is fine.
So the other significant revision that was discussed was had to do with the discovery that fragmentation reassembly in RFC 9171 BPv7 is not really going to do the job, largely because it's incompatible with much of the functionality in BPsec that we really want to preserve, regardless of the fragmentation state of data. So given that constraint, it would be desirable to do segmentation reassembly somewhere else, and a leading candidate, I think, for this is to do it inside BIBE. Segmenting the bundle that's about to be transmitted that is too large, but is already serialized, segmenting that into just chunks of abstract, opaque data, encapsulating those chunks, those segments of that serialized bundle into the payloads of BIBE bundles, and reassembling when all the BIBE bundles containing the segments are received at the BIBE transmission destination. This would enable the original serialized bundle to be reassembled, bit for bit, identical to what was going to be sent, in much the same way that any convergence layer protocol will do, so that all the standard BPv7 processing can be applied. In particular, this is desirable because it enables security to be applied to the segment bundles that is completely distinct from and divorced from the security that is applied to the original bundle, which is invisible until the original bundle, serialized bundle, has been reassembled. There was general agreement, I think, within the working group on this, but I would say not consensus. There's still some reservations, so I think that is still under consideration, and is worth discussing on the mailing list. And that is the end of my slides, and I will now turn it over to Alberto for his. I will stop sharing.
Thanks, Scott, and good day, everyone.
Hello, you were just approved to share slides.
Chair Hatton, quickly, Alberto, can you after the presentation pass the slides through to the chairs so that we can make them available to remote attendees who've got?
Yeah, we'll do so. I'm sorry for not doing that on time.
It's fine.
I think it is this one. Yeah. Oh, sorry. This is not the one. So let me go back here. This is not the one. Sorry, folks. I need to screen share again. Oh, there you go. This one. Awesome. Thanks, folks, and good day. Just wanted to provide a little bit of the operational experience and results of using BIBE in a practical network. We set up that this test happened around a year ago, where we basically tested BIBE in the setup and operations of a DTN network in the ISS for 18 days, or between the ISS and ground. And going straight to using BIBE, basically we established the concept of a service provider gateway. So there is a service provider gateway in the ISS and a service provider gateway in ground. And we use BIBE between the service provider gateways as a way to, as you may imagine, isolate concerns like forwarding, plane, and security policies on that. So we basically established a couple of configuration elements. The first one is what we used during the 18 days. So that was the standard setup where a vibe was applied in the data path between the ISS and the ground gateways. And we used source destination based forwarding rules. And the payload nodes, basically, that are the nodes that generate the data. The data was encapsulated on a vibe, and basically having a separate security configuration, which is, as you know, one of the benefits of vibe, and then also performing bundle status reporting to the DTN manager in this case. During the 18 days, we also set up a specific test to test the bundle retransmission method, BRM, to basically validate custody transfer-like capabilities for vibe. As you know, BRM is different than custody transfer in the sense that custody transfer traditionally is hub by hub or node by node. In the case of BRM, this is only executed between vibe nodes. So in this case, it's just end-to-end or between the gateways. If there is a node in the middle, that node will not basically be doing or reporting custody or acceptance of the bundle. Just a little bit more details. If you look at this is basically the setup of nodes. There were 6 nodes involved in the data plane. If you look at the bottom side, that's where we applied a vibe. So you look at what is in light green, which is a service provider domain, and in the user to service provider interface, basically the interface that connects the payload nodes that are in blue to the gateway nodes that are in green. That's where we applied the service provider interface using vibe. And basically what it was doing is based on source and destination. In this case, source is at the node on the left and destination is the node on the right. And then if you do it bidirectional, source and destination are inverted. We applied vibe on that with a separate security configuration. So basically there was a security configuration that is end-to-end, that is from between the blue nodes, and then a security configuration within the vibe domain or the service provider domain. And then the interface on the radio link, which is the interface between the 2 gateways, that basically was using the LTP CL red, which means reliable LTP, and then the convergence layers on the between the payload or the local, let's say the local interfaces was using TCP CL. We were able to validate vibe functionality in a space network. The big conclusion is definitely vibe provides a good or proper separation of concerns. When we say concerns is, how do you, for example, ensure that you can provide security in the network without necessarily knowing the security configuration of the payload node concern. And likewise, without exposing your security configurations inside your service provider network. And the same thing with the forwarding rules, and vibe provide great separation of concern for that. The main effect, as you may imagine, that we found on vibe, and this is very implementation specific. In our case, we were using ION 413 or 412 and 413. The main effect of using vibe has to do with the affectance on the processing power capabilities, CPU and primarily CPU and memory utilization. But these are things that you can plan. A lot of great lessons learned when it comes to BRM. During our ground testbed sessions, we pretty much immediately discovered that the current timer-based retransmission algorithms algorithm implemented is basically too prone to flood the network in case the link it doesn't behave as as you have specified, whether it is on the bit error rate or the configured data rate in the contact plan. We were able to flood the network pretty easily, and that made us, not using BRM by default, but just using BRM in specific cases. So there are important configuration decisions to make. For example, the TTL, because that's ultimately the only thing that can prevent BRM to flood the network forever and ever. Based on the findings, Carlo Crainis and the University of Bologna and his team have implemented on the Univo BP implementation some of these enhancements to prevent that BRM flood the network, and they include a backoff, exponential backoff on the retransmission timer, and other considerations to ensure that the same bundle is not retransmitted and retransmitted and retransmitted without consideration of what happened in the past, or the effectiveness of the retransmission for that matter. And then the whole goal is to, in a very autonomous fashion, prevent flooding of the network. The reason we're presenting this here is because we believe that the same situation applies to any form of timer-based custody transfer. So as the team, especially on CCSDS, continue working on the compressed bundle reporting and custody transfer on that area, it is very important that these considerations are taken into account. We're going to be publishing a paper soon about the whole demonstration, so I'll share it with the group once it is available. And with that, that's it. Thank you.
All right. Alberto and Scott, thank you very much for those updates and those conclusions. Pause for a moment. Any questions for either Scott or Alberto? Okay. Next up on the agenda, there is a draft submitted for an update to RC 4838, 4838 biz, presented by Scott Burley.
And I will present from here. Okay. Starting with the original RC 4838 architecture document, it was published in April of 2007. Many authors, and the contents are probably familiar to anyone who's looked through this before. I mentioned the contents at this point because there is a variation in the contents structure that I'll be talking about in a minute, and that's by intent. The motivation for developing a new update for the architecture document for DTN is, I would say, twofold, maybe 2.5-fold. One is that it's important to get this documentation into the IETF engineering document stream. It was originally published, the original 4838 was published within IRTF. The architecture is now mature, and this informational RFC really belongs within IETF. Second, we have spent some time looking at this over the last 18 years and have learned a few things and acquired greater understanding of some of the issues that were addressed in the original document. So some updates are really appropriate. In particular, the updates that that reflect implementation and exercise of the protocols that were contemplated in 2007 and have now been standardized. And then, in addition, it seems a good opportunity to recognize formally Adrian Hook's contributions to the work. He was not an author on the original document, but his energy was key to making the Tolerant Networking happen at all. And this is a good vehicle for permanently and formally acknowledging Adrian's contributions. The general plan for the new draft is most of the changes in the text are removal of concepts that have been overtaken by events. There are things that are that seemed like very good ideas at the time that we've discovered, oh, no, not such good ideas. And in addition, the thing that I was alluding to earlier, there is some document structure that we've borrowed from RFC 8655 that you'll see in the revised table of contents. The draft has been developed in Markdown to take advantage of the Internet Draft publication procedures that have evolved over the years. The 00 edition of the draft was published on July 7th. And the link is here, but you can certainly get it from the DTN Working Group webpage as well. Here are the revised document contents. There's, of course, an introduction, and that introduction is somewhat expanded. And there are some sections of the original document that have been incorporated into the introduction. There's a sort of canonical conventions section. There's a lengthy section on terminology, centralizing in one spot early in the document a lot of clarification of key concepts in the DTN architecture. There's a fairly lengthy section, and this again is adopting this somewhat different document structure. There's a fairly lengthy section on providing the DTN overlay service, and that section comprises quite a lot of discussion of quality of service, including the custody transfer concept, which I will come back to later, and also priority, not a complete quality of service discussion, but some core quality of service considerations. The postal style delivery options that were originally introduced in the original 4838 document. Then that's followed by the DTN architecture description itself, and going through mostly the same kinds of sections that were in the original document, with a little bit of rearrangement and changes in emphasis. So the store and forward concept, endpoint identifiers, the use of URI schemes, the late binding concept, some more detailed discussion of the primary block fields in the bundle, and then the other fields in bundles in the extension and payload blocks. There's a discussion of routing and forwarding, focusing on routing and forwarding mechanisms based on contact plans. So there's an analysis of types of contacts. There's a section on reliability in DTN transmission and custody transfer. There's a section on DTN support for proxies and application layer gateways, which are becoming more important now that we're starting to look at supporting applications over the network. A brief section on timestamps and time synchronization. I think a useful discussion on congestion and flow control, pointing out how congestion control and flow control at the bundle layer are sort of innately quite structurally different from within the internet. There's a section on security, talking mostly about the BP security protocol extensions. There's a section on administrative records, which calls out specifically the bundle status reports. There's a section on state management, which is inherited from the original document, application registration state, bundle routing and forwarding state, security state, and policy and configuration state. And then there's a section on application structuring and a section on convergence layer considerations, talking about what's expected from and provided to the underlying protocols for running bundle protocol over multiple underlying networks. And then a summary, security considerations, talking back to the security section, and IANA considerations. Just a little bit more detail on what is new in the document. The initial thing that one will see reading the document is that the introduction is longer. There's a lot of discussion of motivation for the architecture that was moved from section 2 of the original document into section 1, the introduction. There's an introduction of bundle protocol early in this section, and there are some remarks on flattening the stack, that is, adding capabilities as protocol extensions instead of protocol layers. And I'll have a couple more remarks on that in a few moments. There's again, a detailed section on terminology. That's all new. Some of that terminology was present in the original RFC 4838, but it's been augmented as we've added concepts that are important to the operation of the architecture. There's a description of the service that again is an organizational change inspired by other similar documents. There's an explanation of custody transfer as a concept, not going into the really exhaustive detail on custody transfer that RFC 4838 went into, since that mechanism has been excised from RFC 9171. And I'll have another note on that in a moment also. Discussion of the various priority strategies and the postal style delivery options are included in the service rather than separately in the architecture. And then I think most importantly, and I say most readily visible for anyone who's comparing the documents, the fragmentation and reassembly discussion has been omitted, since we now know that the way it was originally contemplated is not going to work well, and we need to do something different. So it's omitted from the architecture, as it's not really handled by bundle protocol. It's still an important consideration, and exactly how we should discuss it in the architecture document, I think, remains an open question. And then, as I mentioned, there's a very lengthy discussion of custody transfer in the original RFC 4838, and that has been omitted because custody transfer is likewise removed from bundle protocol. Talking about custody transfer a little bit more, this is some of the text from the document. And it's intended to clarify the original thinking behind custody transfer and how that original thinking is important to retain, but the mechanism that was built on that original thinking had deficiencies that have, I think, been amply documented over the last few years. And it's brought out here that the concept of custody transfer really dates back to the mid 90s when the CCSDS file delivery protocol was being developed, and we were talking about the extended procedures of CFDP, and the idea being that the environments that DTN addresses are different enough from terrestrial internetworking to motivate relaxation of the end-to-end argument that governs the internet protocols, the retransmission of lost bundle data from the source, which would be the end-to-end approach. It may take so much time due to very lengthy signal propagation delays and punctuated connectivity that the delivery of the retransmitted data, delivery of the complete data, including all the retransmitted data, might not happen before the expiration time of the original data is reached and the data simply go away. If instead the retransmission is allowed to occur inside the network, then the delivery latency can be sharply reduced. That principle, advancing the retransmission point from one forwarding node to the next along the end-to-end path, is what we referred to originally as custody transfer, and that concept is still preserved in the way we organize the delay tolerant networking architecture in the bundle protocol. That is, we use reliable protocols in the underlying networks so that there is reliability point to point, advancing from the source to the destination in order to assure reliable delivery at the final node. Selecting and invoking those underlying capabilities is really important in provisioning quality of service for DTN. And then a few remarks on the concept of flattening the stack. This is a core design strategy from RFC 4838 that is like mentioned in the introduction, but not really articulated and not really motivated in the rest of the text. And there's a little bit more motivation in the new draft, and it may be that some more discussion is merited. What the new draft says is that the DTN architecture is aimed in part at flattening the protocol stack and enabling the scope of operations of the bundle protocol to be amplified by inserting extension blocks, similar to what happens in IPv6, and including things like the block integrity block and block confidentiality block in PPSec. And also by the definition of new additional administrative records operating within bundle protocol, but delivered to the administrative elements of nodes rather than to application elements, that enable bundle protocol to do more things at the bundle layer without imposing the need for additional layers of protocol. Just a little bit of discussion on what that looks like. When you think about the structure of layering versus extension, it actually ends up sort of looking the same. It's just a difference in sort of in the order of header elements in the bundle that's finally of the data that's finally transmitted. So with layering, you have an initial protocol data element, and with an additional layer, you encapsulate that in another in a protocol data unit of a lower layer protocol. With extension, you can essentially do the same thing. It's just that the capabilities that are identified in the header mostly of the encapsulating protocol are migrated into the extensions within the original protocol, so that the original lead header block remains in the lead, and processing is somewhat simpler because all the protocol data elements that come in look the same. You can sort of summarize the disadvantages and advantages of the two approaches in this way. Layering has the advantages of a very clear separation of functions, and in particular, it's easy to swap among different implementations of different protocols at different layers of the stack. The protocols themselves are individually simple. There are some disadvantages that have been recognized in literature talking about flattening the stack, in particular for newer telecom standards. Coordination of different functions entails what are typically termed layer violations and are frowned upon. It can increase the overhead if there's any repetition of information in header parameters, and it can make configuration of the stack more complex. Conversely, extension has the advantages of simplifying coordination among multiple additional increments of functionality, and you can sort of make more holistic forwarding decisions because it's easier to look at all the information at once if it's all in the extension blocks of the data block that you're looking at. It can enable a little bit of compression if there's any repetition of header data in the headers of different layers, and it can simplify configuring the stack because you've got fewer layers of protocol in your deployed stack. The disadvantage is that those additional functions are integrated, which means that you get an implementation of the protocol, you get with it the implementations of all the extensions, and it's difficult to impossible to swap out different implementations of those additional functionalities. And then the protocols themselves, of course, are individually more complex. We've come across this in discussions of BIBE, for example, the idea that you can do bundle retransmission inside BIBE. Well, it's a capability. It needs to be done somewhere, maybe, but it makes BIBE more complex. So there's an argument against doing it there and in favor of doing it at a different layer. These are ongoing considerations. There's no clear answer one way or another, but the ability of bundle protocol to support both, I think, is a strength in the architecture. And that's, I think that is all of my slides. Oh, just one saying that the current draft expires in January of 2026. So please comment on the mailing list, and let's take this draft forward. Thanks.
All right, Scott, thank you very much for that. Chair hat off, very excited to see an update to the architecture document, particularly where we think things were were no longer necessary, and to see the observations that had been added. Since this is a relatively new document, the request, of course, is for everyone here to take a look at it and to have some active mailing list discussion on it. Okay, I think I'm next.
Yep. So next up, Ed. Let me find the slide.
So I also know that we are running about 10 minutes behind, and I know we had a pretty stacked agenda. So I'm going to try and go through this relatively quickly. There's been, next slide, please. Historically, and as Scott just mentioned, as we've gone over RFC 4838 and 4838 biz, there were some original comments on DTN reliability as it intersected with custodial transfer. The original basic service for DTN was bundles would be unacknowledged, prioritized, best effort delivery with sort of a postal style delivery option. And then there was this idea of enhanced reliability where you could get end-to-end acknowledgement through a mechanism called custody transfer, where presumably you would sort of inchworm your way through the network, presumably with every hop getting you closer to a destination. There was a mechanism put into BPv6 for that purpose, but it had issues. The BPv6 mechanism was flawed. There were pathological cases and some non-pathological cases that could cause it to not work. For that reason, custody transfer as an individual mechanism was not carried forward in BPv7 RFC 9171. And there was some thought that perhaps a mechanism would come back as an extension block or as a characteristic of an underlying convergence layer protocol access through a convergence layer adapter. Next slide. As we have worked in the years since the publication of BPv7, we have not seen yet a good single end-to-end formal definition of what reliability in a delay-tolerant network means. And this has caused sort of certain consternation as people want to ask for, either in acquisition or service specifications or just generally as users, how do you ask for reliability without saying the word custody transfer or without presupposing a particular mechanism or protocol? And without sort of a formal definition of that, because custody transfer as a definition was removed in BPv7, we think there's value in trying to define that generally for DTN. Such a thought might get us to whether or not a custody transfer protocol is necessary, and it will allow us to reason about the characteristics of our underlayments and our convergence layer protocols, how we signal things to users, and just generally what that would mean for applications that may say, I want to put my data into a time variant network, which may not deliver the data for minutes or hours, but when can I delete it? Which is an important consideration. Next slide, please. So my supposition with chair hat off is that an informational RFC that tries to describe DTN reliability would be very, very useful. And this idea of custodial transfer, of taking custody of particular data, is possibly not its own protocol. The signaling of it may be a protocol and standardized, but the behavior of custody transfer might just be a behavior of the network. Networks have policies for retransmission. DTN networks have policies for store and forward and bundle storage. Some of these policies don't need to be carried in band in a bundle. They are external. If we start talking about who stores a bundle and for how long, we may want to whitelist who are custodians for data. We may require some minimum or maximum number of custodians in a network. We may, at segment points, deal with reliable or unreliable underlays, and that may affect where we think custodians are needed. But these aren't part of a standard protocol. This is part of policy and configuration and network architecture, and we should allow for network architecture and policy and configuration to be part of the discussion of what reliability means. So if we are able to make an informational RFC, we might be able to include a more holistic reasoning about reliability and also maybe provide some definitions of that reliability that span a spectrum of the kind of services we would like to provide for our users. Next slide, please. So there is a draft coming. Did not quite make it in before the upload deadline, but it will get in shortly and will be posted to the mailing list. We took a look at reliability from the sense of taking a logical bundle node from RFC 9171, which is the picture on the left, looking at sort of the simplest non-trivial network between a sender and a receiver with a node in the middle that it could talk over reliable or unreliable underlayments. And we wanted to do some reasoning around that to try and give some definitions to reliability and some reasoning behind why that might be reasoning about it holistically. Next slide. So the general approach is to go through that logical architecture and say where from the creation of a bundle to the delivery of a bundle, or the creation of the ADU and the delivery of the ADU, could something go wrong? And across that area, what are the categories of faults? And from there, where and how would users need to get indicators that something good or something bad happened? And a user could be the original creator of an ADU, or if you have a network that is peering with another network, then one network can be the user of the other network. Then from there, how do we define reliability for DTNs, understanding the fault analysis and understanding the indicators that users would want? And from there, how do we reason about the kinds of reliability mechanisms that would be available to us across this logical architecture? And then lastly, could we then define classes of reliability that we can talk about in a more standardized way? And then I'm going to go through each of these very, very briefly. Next slide. So fault analysis and user indicators. What can go wrong and where? In the 9171 logical architecture of a BP node, you have an application agent, you have a bundle protocol agent, you have a convergence layer adapter, which is your entrance point into what is perhaps a deeper convergence layer protocol stack. And then you have behaviors of the underlay networks. And you can look at each of those and talk about broad categories of failures where bundles could be lost, they could be mangled, they could be otherwise perturbed. And you could put together a relatively small, tractable amount of categories of information or categories of failure, and how you may or may not be able to address those if, for example, you had certain reliability guarantees or signaling at any one of these interchanges between logical elements of the architecture. If you're a user, you may want to understand beforehand how your data may be associated with how it is treated and the reliability it needs. You may want to understand whether the network accepts or rejects the traffic that's coming in, and you may or may not want either direct or third-party reporting of individual pieces of data or overall data volumes. Next slide. If we then from there say, here are things that could go wrong and here are things that users might want to understand, we could then try and talk about what does reliability actually mean. And reliability, typically means you can rely on the network. It has some level of reliability. But in a DTN and in a store and forward, or generally a challenge network, then that reliability comes from other ilities associated with the network. One of them, of course, being resiliency. And we talk about in this draft resiliency as the ability to tolerate a more diverse set of operating conditions. Availability, typically for a network, means end-to-end availability. The network is available for end-to-end data exchange. However, in DTNs, if you do not have a simultaneous end-to-end path, availability might mean the original source node that would accept your data is available to you and willing to store it, and we believe we have a path over the lifetime of the data. And durability simply meaning we can hold that data and we don't either throw it away or otherwise lose the ability to reason about it while it is in the network. And if we work through that, we can then clarify uniquely what do these concepts mean in terms of DTN, which I've just summarized. Next slide. From there are not many mechanisms in place to deal with reliability. There are sort of two categories. One, of course, is some kind of acknowledgement, either positive acknowledgement or negative acknowledgement, NACs, and you can apply them either at the application layer, at the bundling layer, or essentially below that. And then there are delegations. If I know in my network architecture that I have some level of trust in my underlay network because of the protocols that are there or how it is run, or in how my applications are running, those are hints to things that we can control as part of network architecture, policy, and configuration. Next slide. And If we work those through, we could then come back and say, there might not be a binary, is the DTN reliable or is the DTN not reliable? We might wind up with a staggering of ways of talking about reliability. One, and these are simply four that I would propose. One is sort of a class 0, no reliability, no bundle layer reliability. I'm not even agreeing to sort of store your data. It's just there. Class 1, best effort, time variant, store and forward. I happen to have storage on certain nodes just as part of being a DTN node itself. I may take it and store it until it ages out, or until someone who has paid me for storage is going to come in and push you out, or something else. And then higher classes of reliability that talk about more guarantees around how data would be stored, and or how the network would ensure that your data only goes over reliable links in between guaranteed storage. But the idea here is that there's not necessarily a protocol end-to-end that needs to negotiate this. These can become properties of how data is handled within a network itself, with the idea that a network could accept custody of the data, and the network, through its design or architecture or preserved storage or only use of reliable underlayments or other mechanisms, will make sure that your data is handled correctly. Last slide. So generally, I think there needs to be some statement on the definition of DTN reliability. There are many piece parts that have come up over the past 4 or 5 years. I think that reliability is a function of the services at the BP layer. It's DTN reliability at the BP layer. And it's going to be informed by architecture, convergence layer protocols, underlayment capabilities, and application capabilities. And we should start thinking about custody transfer not as an individual protocol, but as a characteristic of a network that has been architected and configured in a particular way. Now, that's different than some of the work happening in CCSDS that says, how do we signal that for a bundle or a group of bundles or for a user, we will explain as a user indicator back that we have accepted or given you some reliability. And I think that signaling needs to be standardized. But the builders of DTN networks themselves have a lot of tools in how they can try and ensure that user data is not lost. And so a definition of reliability that allows individual network providers to architect that reliability into their systems, I think, would be a powerful tool, and we would propose an informational draft for that purpose. So I think that's my last slide. Chair hat off. What do you think?
Ronald, you're in the queue. Can I note, while Ronald is standing up, I know, Stuart, you've been making a number of comments and questions and taking some notes. I assume that means you're not going to join the queue. You're going to take it all to the list. Go ahead, Ronald.
Hi, Ronald Lindveld, banging on the same drum forever. Does your analysis take non-singleton endpoints into account?
The current draft does not take non-singleton endpoints into account, and it probably should. So my first goal is to get the -00 as a personal draft out and get that discussion started.
Scott, go ahead.
Just one point on reliability mechanisms, and it's an uncomfortable one that I think we have to not overlook, which is retransmission driven by timeouts. Without that, without timeout-driven retransmission, you really don't have reliability, and yet the computation of retransmission timeout deadlines is a difficult problem in delay tolerant networking that is going to take a lot of head scratching, I think.
Just as a comment, I completely agree, but the hope is that if we can define custody transfer as a characteristic or network behavior, then that may give some freedom to the implementers of those networks to figure out the mechanisms that work best for them.
Sure.
Brian, go ahead.
Thanks. One other topic that might be helpful in this kind of thing is the discussion of measurement, to be able to kind of explain that like you said, maybe your underlay gives you the reliability. If you can measure that and justify it, it helps out.
Oh, I absolutely, completely agree.
Scott, I think you've still got your hand up in the queue, but Juan, go ahead.
Quick question on my side. So I understand the custody as a mechanism, as a behavior of the network, but doesn't a reliability definition would also impact the selection of the CLAs that you can use along the path, not besides the managing of the bundle on the custody level?
I completely agree. It makes great sense to me that if certain data is tagged for a high level of reliability, that would impact and filter the CLAs and the underlay networks that would need to be chosen as part of that architecture. Well, this seems reasonable to me anyway.
Alberto, go ahead. I've shut the queue because we're so short on time. But
thanks, Ed. Quick question. Where do you envision signaling the reliability class?
Yes, I think I would, in the interest of time, I will simply say I think there are a couple of mechanisms by which you could signal how you are treating the data and how you need your data treated individually as a user. We could talk about expansions of service level agreements to include quality protection and quality of storage and reliability guarantees. So I think all of that is in band, and the purpose of a draft like this, and certainly seek feedback and contributions, is to just help build out those expectations and definitions in a way that allow implementers to implement in ways that make the most sense to them, while still giving a standard for how we define these reliabilities and service classes.
Okay, thank you.
Thank you very much, Ed. I am going to find the slides for the next presentation, which is going to be given by Benjamin Dowling rather than Cezanne Chen, because availability, I believe. So this is
correct.
A strong bundle audit mechanism. So I'm showing the slides. Sorry, Benjamin, you could have chosen to share the slides, or do you want to show next slide to me? Your preference.
I can just take the screen share if you would like.
So if you stop the screen share.
I will stop the screen share before I say yes. It's useless at this tool. Go ahead. It should be coming through.
It is coming through now, and I just need to hopefully share the correct screen here. Yes, everyone can see my slides?
Yes, we can. Go ahead.
Excellent. Thank you very much. All right. Good evening. My name is Benjamin Dowling. I am a lecturer at King's College London, and I'm here to talk about our new draft, which is securing BPSec against arbitrary block dropping, along with my co-authors who are listed here. So a few months ago, we started, we had a publication which was looking at BPSec and providing a cryptographic analysis of the security guarantees of the BPSec protocol. I wish I could take credit for the title. This is my co-author Britta Hale's joke, unfortunately. So just to quickly summarize kind of our results and the scope of our security analysis before addressing what our draft is about. So we're looking at the bundle protocols security. So this is a mechanism to ensure integrity and confidentiality of extension blocks and payload blocks within the bundle protocol. So our analysis assumes that these are pre-shared keys and in particular symmetric keys. So these MACs and these encryptions, these are symmetric key primitives and protocols, which means that this achieves no perfect forward secrecy and no post-compromise security, but this is not terribly surprising. So these security blocks, just to discuss them a little bit, to talk about the security guarantees, these are a type of extension blocks which provide authenticated encryption, providing confidentiality, and integrity blocks, which use MACs for data authenticity and integrity. Just a quick representation of the BPSec kind of bundle and each one of the blocks within it. So we have a header, a primary block, which contains essentially routing information, source, destination, creation timestamps, and things like this. We have our extension blocks, which we're only going to be looking at security blocks for this presentation. So this is the BCBs and BIBs providing confidentiality and integrity. It contains a list of information necessary to be able to provide and process the security operations. So this might be algorithms and parameters, a list of security targets that this security block applies to. So for a BIB, this might be a MAC over a couple of different extension blocks or payload blocks. For a BCB, this would be a pointer to a particular target that an encryption operation has been applied to. And then finally, we have our payload block, which is meant to be processed by a destination. And so when we were doing our analysis of this protocol, one of the things that kind of really jumped out to me about the BPSec protocol was this intermediate node processing behavior. So in BPSec, we have this mechanism that allows intermediate nodes to process blocks on behalf of the destination. So we have this kind of example here on my slides, where at T0, the source creates a message which has security blocks, so BIBs and BCBs, and then they store and forward it into an intermediate node in the middle here at time T1. This intermediate node has security policies and permissions, and in particular keys, that allow them to process some of the security operations that are occurring within this block. So we can see here the intermediate node processes one of these BIBs, and because they've processed it, they now drop it. And then when they forward the message onto the destination, it consists only of the blocks that haven't been processed on its behalf. And so one of the questions that our analysis kind of prompted or provoked was like, who processed this block? Who processed the bundle? Because the mechanism as BPSec currently defines it cannot differentiate between a bundle that's been processed by an honest party that has the correct keys and the correct security policies in place to be given the permissions to do this, versus an adversary that receives a message, doesn't like parts of the message, particular blocks that have security operations applied to it. They can't change the actual block itself, the thing that's being integrity protected by a BIB or a BCB. And so it simply drops the extension block and the security blocks that apply their operations to this thing. And so the destination can't distinguish between these two settings. And so this would allow for arbitrary block dropping within Deep Space Protocol. So we're kind of back to the example that we gave before here, where we have satellites that are trying to communicate. The source generates a bundle. It then sends it on to kind of in an opportunistic fashion onto an intermediate node. This intermediate node, unlike the previous example, doesn't have the permissions, doesn't have the keys in order to do this processing, but is an adversary and doesn't like some of the blocks. So it simply drops these things. And then it forwards this message onto the destination, who has no idea that anything has really occurred here. And so in our analysis, in our paper, we introduced this additional mechanism that we call strong BPSec, and essentially it's an auditing mechanism. So it applies two additional layers of integrity. We have receipts, which are applied by intermediate nodes that process blocks, and we have an auditing node, an auditing block that is generated by the source node on its way to the destination. And so what this guarantees, this additional mechanism guarantees to the destination, is that all of the blocks, all of the security blocks that were added by the source have arrived essentially completely unchanged, or that there has existed some honest intermediate node, which we define as they have access to the same keys that allow them to process security operations on behalf of the destination. Some honest intermediate node has correctly processed and discarded the blocks. So as an example, so this means in particular that our strong BPSec mechanism allows a destination to distinguish between the two settings that we talked about before, where we have a bundle that's been processed by an honest intermediate node and an adversary who has simply dropped some of the blocks that it doesn't want the destination to see. So BPSec allows you to get this guarantee. So what does this kind of look like on a high level? So we have on the left-hand side the source, and they create a bundle. And this bundle is made up of the header block, the payload block, and a series of extension blocks, some of which are security blocks that apply security operations to other blocks. So we can see here on the top, we have a BIB. This is applying a message authentication code to another block. We have two BCBs that are encrypting block 4 and the payload block. Okay. In addition, however, the source node will now also create what is called an audit block. This audit block is essentially just a MAC with a key that it shares with the destination node, and it essentially integrity protects and authenticates all metadata of all security operations that the source generated. So it contains metadata information for this BIB, this BCB, and this BCB here. Now, if an intermediate node receives this message, what is it going to do? Well, it's got the keys that allows it to process one of these blocks, let's say this BCB2 here. And this also allows it to process block 4, which was confidential protected by the BCB. But now what it's going to do, in order to prove to the destination node that someone hasn't simply dropped this block maliciously, it's going to add what we call a receipt. And this receipt is essentially a MAC. The MAC is keyed with a key that shares with the destination. And this is over the metadata of the BCB. It essentially is a receipt to say, not only did I process this particular block with these particular characteristics, but here is a proof that I have the key that allows me to do this thing. And so by the end of this, the destination will receive this kind of shortened bundle, which contains the original BIB, the original BCB, but also this receipt for every security operation that an intermediate node has processed. And using the BAB, it's able to verify all of the security operations are still either there, or there is a read receipt that is generated by an honest node that allowed them to process a security block on the destination's behalf. Oh, sorry. We presented this to CCSDS, and there seemed to be some engagement and some excitement with this. So we created a draft to improve security for BPSec using this strong BPSec mechanism, which we call the strong BP auditing mechanism. And so you can find that draft here. And so this presentation is mostly a request. I am an academic. I've never done an IETF draft before myself. So this draft is probably missing a lot of considerations that I imagine we would require in order to propose this for working group adoption. So we're looking to solicit feedback for getting us into a position where we can propose this for adoption. We have some specific points that we would like to hit on for specific feedback. In particular, I realize that I don't have a lot of time, and there might be some questions for people, so I will go through this very, very quickly. So the first one is we introduced this notion of key identifiers for the security context, because colliding key identifiers might impact the correctness of running the strong BPSec protocol. So some additional feedback on how feasible unique key identifiers is in this space would be very welcome. We have a paragraph on cozy context considerations. So because of our assumption that all the BPSec was based in symmetric key primitives, all of our work is kind of phrased in symmetric key primitives. BRBs and BABs are defined essentially as MACs, but we think our framework is robust enough that we could use asymmetric primitives like signature algorithms to support cozy contexts. So some feedback on what this might look like would be helpful. In our analysis, we assume that BRBs and BABs are additional types of blocks. This simplified the analysis for us, but this means that we now need to define new block types in the draft, and this might be contentious. So we're looking on feedback for ways that we can do this or ways that we can get around this. There might be some blocks that are excluded by the SBAM. In particular, any blocks that necessarily change over the course of the bundle lifespan would have to be excluded from these sorts of operations, possibly bundle and bundle encapsulation blocks. So some feedback on which blocks would be difficult to contain within our framework would be helpful. And then finally, we have some ideas about a possible efficiency extension. So SBAM necessarily introduces overhead. There's this BAB. Every time you process a security operation, you replace it with a BRB. So maybe we can collapse multiple BRBs to save the total number of blocks sent. But this hasn't been analyzed or really fully developed here. So some discussion on this point would be useful. And that's my presentation. Thank you very much for your attention. And I see there's already questions.
Thank you, Benjamin. There are people in the queue. Go ahead, Brian.
Yeah, thanks for this work. My one strong feeling about what your current draft and your current presentation contains is right now it mixes data being conveyed with security on MAC of that data. And I think that if you need to perform security operations, if you need integrity, then using an existing bib on top of your extension block would be valuable, rather than it allows you to have algorithm agility that right now you would not have.
Okay,
And
so
we can talk
you're
about it in the
talking
mailing
about,
list.
yeah, we can talk about it on the mailing list, but thank you for that. That's very helpful.
Thanks, Brian. I'll be quick. So this is Rick with the chair hat on. I think it'd be really useful for the working group to review this, because although I think the concepts are really strong, as Brian said, there's some elegance that could be put in by using a bib instead of putting the integrity value into the BRB. There's a couple of little assumptions about, oh, BPSec is only using symmetric keys. That's actually the interoperable context defined in 9173 rather than 9172 itself. Some minor inaccuracies. Personally, I'd make one request. Strong BPSec kind of implies that not strong BPSec is what we have at the moment, and that's not the right message. So this is more adding some ledgering capability to it. So a slight issue with the word strong, but that's a personal opinion. Otherwise, this is good work, and I personally support it.
Ed, chair hat off for a moment. Completely agree. The BAB and a BRB, they can also be dropped in the middle of a network. So we may want to also just make sure what we think we can achieve there. The second with chair hat on is in RFC 9172, section 10 talks about the ways in which new security blocks could be added if they add value. And so as I look through your internet draft, what I think I'm seeing there is a proposal to write up, here are two quote unquote other security blocks and how they would work with BIB and BCB. And I just personally would really like to see that work evolve in that way. So just a thumbs up and thank you for presenting.
Thank you.
One last comment following on from that, because it just occurred to me. You asked a question in here about whether multiple BRBs, you get an explosion of BRBs. I think and I need to revisit this in a bit more detail. So a standard BPSec compliant security block generally has the capability to target multiple things within the content of that block. So being able to have multiple BRB entries within a single BRB seems to be the right way to go. But we're very short on time, so I'm going to kill the queue and shut up.
And with chair hat on, I just want to say thank you to everyone here in the room and online. We are out of time. We did want to have a recharter discussion just because there are some drafts coming and that have already been added that warrant discussion, but I think we're going to take that to the mailing list. So otherwise, thank you all so much. We will see you at 124 in Montreal.
And speak to you on the list virtually.
Yes. Thank you. Have a great day.